In my lab 3, I was supposed to use the position data of an orbiting star around a black hole and determine the mass of this black hole. And we can do this by using Newton's second law and then relating the position data we were given and finding the relative velocities, and using that finding the change in velocities, and then use that to find the change in momentum over the change in time, which is equivalent to the net force acting on the object. And then we can use the net force in the gravity force equation to determine the mass of the black hole. And as a result, the black hole mass equals 3.582 times 10 to the 31 kilograms. So now I'm going to run through the process of which the computer model uses to determine this mass. So we have these position vectors right here, these position points, and we can, between each two position vectors, we can find the velocity, which just equals the change in position over the change in time. And so between each two of these positions, we find the velocities, and then between each two velocities, we can find the change in the velocity, and then we can find the change in momentum by just multiplying the mass times the change in velocity. So we know that Newton's second law states that dp over dt, the rate of change of momentum, equals the net force on the object. And we're assuming that dp over dt is approximately the change of momentum over the change in time. So our net force is approximately the change of momentum over the change in time. So therefore, this F net is approximately this change in momentum we find up here over the change in time. And we can find this net force for each one of the points of our data. And so to find the mass of the black hole, we use this net force that we find, and we know that that's the only force acting on the object, or we know that gravity is the only force acting on the object, so the F net equals the force of gravity. So we can use the force of gravity equation and single out the mass for the black hole, and that equals the net force times the distance squared over the gravitational constant times the mass of the star. So that is our method for finding the mass of the black hole. And it's important to note that the net force is not the same as the change in momentum over the change in time. And Newton's second law relates the two, but the net force just refers to the sum of all the forces acting on an object, while the change in momentum over the change in time, which is approximately dp over dt, that is the rate of change of momentum. So, and the parallel and perpendicular components of the net force are also different from the parallel and perpendicular components of the rate of change in momentum in the same manner that from before. So the net force is just the sum of all forces, while dp over dt is the rate of change of momentum. So now I will run our module just to show a visual representation of the star orbiting around the unknown mass, or the unknown black hole mass that we now know. So it takes a second, but I hope you could see it broke down the force components also. And then, so the last part of this lab is the what if question. So we're to imagine that the black hole whose mass you found was removed and a different black hole was placed in the same location. And we're also assuming that the motion of the observed star remains unchanged and is affected only by the gravitational force of this new black hole. Could you tell the difference? So we definitely cannot tell the difference, because we would find the same mass for this black hole as the other one, because the data is all the same and the computer is making all the same calculations. So that is the answer to that question. And these are all of my findings from Lab 3. Thank you for your